He is a member of IEEE Standard Association P2-145 Standards Development Working Group Standard for Framework and Definitions for Blockchain Governance. Currently, he has a consultancy project on high-level software architecture development to integrate healthcare applications of Health and Family Welfare Department, Government of Karnataka. His area of interest are computer networking, information-centric network, cryptography, and network security, and also image processing. He has published several research papers in reputed journals and also a book chapter. He holds MSc in Physics, MTech in Computer Science from NIT Surathkal, and also a PhD in Computer Science. He has earned GATE scholarship also for his MTech course. With these words, I invite Professor Dr. Rajendra Hegadi for carrying out his assignment in the present session. Thank you.
Thank you, sir. Good morning. Thanks for the kind introduction. Let me share my screen. The presentation is visible?
Yes, sir.
Yes.
Yeah, I'll mute. Okay. Good morning to all of you. I thank the team of FDP for inviting me for this talk. I think the program is well designed. In fact, I haven't seen the brochure, what are the program details, but I hope that the program is designed very well. There are eminent speakers across the world. I believe we'll be enjoying the FDP program. Today, I'll be talking on Ethereum blockchain. Is a part of cybersecurity FDP. It is very difficult for me at this moment because I had a very few days to prepare for this. Just maybe 3 or 4 days back, I was called and can we have the talk on in cybersecurity? But anyway, Ethereum blockchain is the one which is coming up. So I thought I can deliver the talk on Ethereum blockchain. I'm not going to exactly link up between cybersecurity and Ethereum blockchain, but we'll be focused on Ethereum blockchain. What are the advantages? How the Ethereum blockchain has evolved? How it has certain advantages over the rest of the blockchains that we will see, specifically Bitcoin. Today's agenda for discussion will be on Ethereum blockchain, its history, types of Ethereum, which all of us might be interested to know, and Ethereum ecosystem. There are different components of Ethereum blockchain platform, which makes the platform a very robust system in which the people are trying to explore new ideas, new things, a lot of research, a lot of applications being done on it. And then we will have a conclusion and Q&A. I presume that all of you have at least a background of blockchain, a minimum idea about blockchain, and a small interest in Bitcoin. Some of you might have invested in Bitcoin also. That's a booming up. I think you might have earned pretty good dollars in thousands. But anyway, we'll see what discussion we can have. So before I start Ethereum, let me discuss difference between Bitcoin and Ethereum. All of us, we know that Bitcoin is booming up. Bitcoin is It is a basic genesis of blockchain system, but it has certain limitations, right? This is just nothing more than a digital currency where peer-to-peer electronic cash system is established. Entities can transfer the bitcoins, that's electronic cash, and there is a small part they can work on what kind of business agreement they have, so that can be noted in the part of transaction. But Ethereum is more, it is a ledger technology used to build a new programs. We can have a more robust platform where we can build distributed applications on the top of the blockchain, which interacts with the blockchain system. And we will see what else can be done with the Ethereum. Bitcoin is less robust, nothing more than just cryptocurrency exchange. Cryptocurrency is, of course, Bitcoin itself, and cryptocurrency here in Ethereum is Ether. Bitcoin, you can write simple applications. Not much innovations can be done in the Bitcoin. You cannot write more robust applications. Whereas Ethereum is more computing frame. We can build extremely complex applications, and it is being evolved over the time. Whereas Bitcoin is been not much being explored for the new innovations, new ideas, whereas Ethereum is being evolved. Most importantly, Ethereum is open for the research. You can write programs, not paying anything. You can build your applications, write smart contracts. All these things are possible in Ethereum. Bitcoin is it maintains a privacy, anonymity, and of course, uh, whereas Ethereum is open for innovations. Ethereum, uh, of course, everything happened after the once Bitcoin came into market. We all know that the genesis of Bitcoin is uh, the famous author who still remains to be anonymous, right? So Ethereum was conceptualized by the Vitalik, a young guy, in 2013. This is a suitable platform to develop smart contracts for blockchain and D apps, distributed apps. What are these smart contracts that we will see when I come to that topic? In contrast to Bitcoin, Bitcoin is supports only a small scripting language, which is limited in nature and allows necessary operations, which are inbuilt operations. Not much innovations can be done. Limited, very limited it is. Whereas Ethereum has evolved, started with 2015 version of Olympic. Then 2015 itself, a new version came, Frontier. This is all because of a new development. And if you look at the versions which are being changed, it's very fast. Within a few span of years, there's a lot much of changes we can see there. Then there is a Homestead version, 2016, Byzantine. It's all try to solve the Byzantine issue problems, general issue problem. And Metropolis Serenity is yet to be released, which works on proof of stake, whereas the current version of Ethereum and the Bitcoin, they work on proof of work, right? There's a lot difference between proof of work and proof of stake. Ethereum is is a transaction based machine, state machine. We all know, we have studied, I think many of you are from computer science, you have studied theory of computations. What is the state machine? We know that. We also know that it is expected to have state machine, complete state machine. for any Turing language, you need to have a Turing state machine acting on the, when you write a program, it should be of the 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 programming language of should be of Turing complete language. So transactions based on the state machines, in a sense, the two entities are the two nodes in Ethereum. They want to exchange certain information, including the Ether, that is a cryptocurrency. They submit, one of them they submits the transaction to the blockchain. So this transaction evolves over the time. It changes its state, and finally it reaches to a very stable state. From that, you cannot change. It is, immutable. So this state transition is recorded in the state machine. A transaction executed incrementally to reach the final state, which is an absolute undisputed version of the state. Here, mining plays a central role in the state transition, and specifically in Ethereum, Bitcoin, uh, Ethereum, Bitcoin, they all work on the mining. Mining plays very important role. World state, in the sense, whenever a transaction is submitted, it is distributed across a network. As you know that every blockchain network is a peer-to-peer network, and we have different blockchains. There's public and private, permissioned and permissionless, so many, right? But ultimately, any transactions which happen and a block is created, which is distributed across the network. So that changes the state of the block. We call it as a world state. So this world state, stored in the Ethereum blockchain. Ethereum is a peer-to-peer network. Nodes maintain the blockchain based on the consensus basis. There are various consensus algorithms. The most important two, anyway, I have mentioned it, proof of work and proof of stake, right? The current version of Ethereum as well as Bitcoin, both they use proof of work. But proof of work has certain greatest disadvantages. Specifically, it consumes lot of resources, specifically energy, electrical energy. So Ethereum is moving now from proof of work to proof of stake for the time. Very soon, this proof of stake version will be released. So there are three types of networks, Ethereum networks. The first one is mainnet, second one is testnet, and third one is private net. As the name itself indicates, mainnet is a main network where you see that Ethereum, the network which is growing, the blocks are being appended, right? And testnet is, of course, you can you can build your applications, you can build your own, network. You can build distributed applications. You can, develop a smart contracts, deploy over this test net, which is equally robust as the original main test. And you do all the research you can that's possible in the test net. And you have a private net, which is private, like where you need to have a permission to get into that network. And if this is a permission, then you need to pay or something like that, which is a private network. So all the three are there. So main network is a current live network that you can see. You go to the Ethereum website where you will see the nodes are being created. You can know what is the height of the node, what is the size of the node, how many transactions are there, what is the gas which is paid for that, how much of Ethereum is it contains. All these information is available there, which is a main network. It keeps on growing. But every node will have the information about which version of the Ethereum is being used. because version keeps on changing, and the business logic which is being implemented, it also keeps on changing. So the code and everything, all information you will get in the version. So version is mentioned in the block. Versions are like Byzantine, Byzantium, that's also called as Metropolis, and chain ID, network identification ID1. Uh, in the ID1 indicates this is the main network. Second one is the type which is testnet. Testnet, as I told, which is used for testing you can build your smart contracts. You can build distributed applications using Turing language. Um, can use C++ or any Turing language, or its own. The blockchain also has its own, language which can be built on, which is more suitable for that. Because being evolved, it requires a certain time to get stabilized. So you have Ropsten, which is the testnet, and which you have Cohen and Rinkeby. Ropsten is a widely used test network for Ethereum blockchain. If you want to build your applications and test them, you can do it on Ropsten, which is a free of course. To test the smart contracts, distributed applications, before you can deploy on the live network. If you want to, deploy it in the live network. So this allows a kind of experimentation and research. You want to build a, research. You can also build your own network like Ethereum, which is ID1. It is there. You can build your own, Ethereum, some other network where you implement your logic. You can create tokens. You can create your own, cryptocurrency. You can build your own empire of, blockchain. That's possible with uh, the Ethereum. So main testnet Ropsten and other Cohen and Rinkeby, which has a part of the Ropsten. Ropsten contains all properties of Cohen and Rinkeby. Obviously, this is a simple Venn diagram. All of us can understand very easily. Then let us come to the private network. Private network is like, private network created by new Genesis block uh, used in the permission blockchain. So you can also create your own private network, but I think you need to pay for that. If you make it as a commercial one, you need to pay for the Ethereum. There are charges that you can go through that. So there are various network IDs. Not only these things, these are the important one which I have listed out. There are private networks which are created for the, say for example, a bank wants to have everything transaction recorded in the blockchain. They can build their own blockchain network using Ethereum. Ethereum is preferred because it's already being proved where you can write robust applications, smart contracts, which are truly not necessarily truly smart contracts, you can say, but being evolved and it is being changed because innovations are accepted, innovations are encouraged here. So it's quite obvious that some of the banks, specifically financial sector, being they are exploring this Ethereum. And one more is IBM also has come up. IBM is getting a lot of the players coming into IBM Hyperledger, which is also a equally robust platform for the blockchain. Correct. So now let us come to Ethereum blockchain. Let us understand what are the total, all the elements, important elements. Like we are not going in depth of complete architecture of Ethereum blockchain. That will be more, it requires a lot of first reading of what is blockchain system, understanding all those things. That is what we are doing right now. So main element consists of crypto keys, and wallet addresses. These are the elements. The first element what I have listed out, crypto keys and wallet addresses, they identify the node in the network. See, in the network, node are not identified by the person or who is holding it. That has to be anonymous, because the very purpose of building a blockchain network is to build a trust in an untrusted environment, right? So untrusted environment, I need not to know who is the other entity in the network, right? But I should be able to do the transactions in the network without any glitch, and any transaction which is being done should be recorded and permanently available in the network. No point of time should be changeable, immutable. And the other entity also should agree at any point of time that the transaction has taken place between two entities. Both the entities need not know who exactly they are, but all other entities can verify this transaction which has happened, right? So this is all possible with the cryptographic fundamentals, right? And the wallet addresses are identified by the these keys. What are these keys? We will see. Yes. And Ethereum accounts are there. There are two types of accounts: transactions and messages. Yes, every transaction has to be recorded there, and these transactions, when they are submitted, they may trigger the messages in the network. And there is Ether, which is a cryptocurrency, or tokens can be used for the exchange of the information for the transaction to happen, right? And there is a Ether virtual machine, which plays a very important role in the Ethereum system, because everything is built on this Ether virtual machine, EVM. We also call it as the EVM. And smart contracts. Smart contracts are that's advantage of writing a code in Ethereum ecosystem. We will also see what exactly these smart contracts, and we will also discuss, are they really smart or just dumb contracts? We'll see that. The first element is crypto keys and wallet addresses. So, as I told you, these are the crypto keys mainly to identify the ownership of an account, ownership of how much of ether they hold, right? As I told you, ether is the cryptocurrency in Ethereum system. And you have every wallet has a pair of keys. One of the key is private, other one is public. Private key is generated randomly, and which remains to be secret with a wallet, and public key is generated using private key using crypto system, right? Addresses are derived from public keys. So if I want to identify a wallet, I will not be looking at who holds that wallet, right? So it is identified by the 20 bytes of public key used to identify the account. 20 bytes is a pretty good number, right? You can which is generated random. The private key random 256 bits is a positive integer defined by elliptical curve SECP 256 K1 algorithm. The private key is generated. As I told you, it is generated using random number, which is a random number of 256 bits, which is generated by using a elliptical curve algorithm SECP 256 K1. And public key is derived from the private key, which is done using elliptical curve digital signature algorithm. At this point of time, I assume that all of you know what is public key crypto system, private key crypto system, what is hashing algorithm, what exactly elliptical curve, what is a digital signature. All these things, I hope you all know it. Okay, I assume that. If you don't know, then we can discuss the time permits at the end. Address is the rightmost 160 bits of KSAC hash public key. That's what I told you. It is 30 bytes, right? Out of 256 bits, 160 bits are used for identifying the address, right? Bits of the, right? That is 20 bytes, 20 into 8, 160 bits. Then second, accounts. Accounts are building blocks of the Ethereum blockchain, right? And with the Ether balance inside the account. There are two types of account: externally owned account and contract account, right? Accounts can be user controlled as a smart contract. Two types of account. This being wallet can control one of the account. The wallet can have externally owned account. So wallet can submit the transactions. So I want to send certain ether. I have made some contract with one of the entity across the world, anywhere in the world can be done it. Contract account are a small contract deployed on the network controlled by the code. The contract accounts are. Both type of accounts can interact with a deployed smart contract, right? Both the type they can interact with. But there is a between both of them: externally owned account and contract account. Externally account, no cost for creating it. Anybody can join it. Anybody externally owned account without paying anything to the mainnet of Ethereum with the transaction ID 1. Am I audible?
Yes, sir. Yes, sir.
Okay, thank you. There was a message for me that internet is disturbed. Okay, so externally account you can create it without paying anything, so there is no cost involved. Whereas contract account requires a cost as it uses a network storage, right? And externally owned account can initiate transaction, whereas contract account can only send a transaction in response to receiving transactions, right? So they cannot create a transaction, cannot initiate a transaction. They can only respond to the transactions. Externally owned account, there is no code associated, because why the code is not associated? Because it's the simplest, lightest account which can only create a transaction and submit transaction to the Ethereum blockchain to take care of it. Whereas contract account, they are more robust. They can handle the transactions, receive the transaction, and respond to the transactions because they are stored in the network. They also absorb the computational power of EVM, Ethereum virtual machine. So they require to be paid for that, right? So if you want to have a contract account in the Ethereum, you need to buy certain ether there. The transaction between externally owned account to externally account by only ether transfer, right? Externally owned account, you can just only transfer the ether. You cannot have more code on it, right? Whereas the contract account, transactions from an external account to contract account can trigger the code. This can, trigger many actions like transfer of. I think somebody has a doubt. Participant. Okay. So actions like transfer of tokens, create an account. That's also possible with the contract account. Say in case if you want to invest some amount in Ethereum, you can have externally owned account. Not much interaction. You can only transfer the account on the behalf of somebody. Somebody wants to do the interaction, then you know that I have so much of dollar with me, ether with me. You can use this and pay dollar to me, right? That kind of thing you can do it, although it is illegal here in India. Ethereum ecosystem, the components, we are into the second component, that is account. Every Ethereum account have 4 fields. Okay, let us look at whether it is externally owned account or the other account. They have a counter. There is a counter, the balance, code hash, and storage root. Right? There are 4 fields. These are the main 4 fields. Counter, obviously, it tracks something. Like it keeps on counting, adding the value. What is that counter in the externally owned account and contract account? We'll see that. Balance is, of course, the balance of ether. Code hash is, which is a code hash which gives us like the integrity. You can always check the integrity of a certain code. And of course, the externally owned account, they don't have any code. Obviously, code hash will be on null, nil, or none, whatever that, right? And storage root. The counter is it keeps number of transactions sent from the account, right? Obviously, in contract account, how many number of contracts are created by the account? That is all, right? In contract, the externally owned account can only create, the transactions. It records that. It keeps a track. Balance is a number of V owned by the account. V is the smallest denomination, like we say rupee, but 1 paisa is the smallest denomination. Similarly, ether, in the ether, the V is the smallest denomination. So 1 ether is equal to 10 raised to 18 V, right? This is kept in thinking that the ether keeps on growing it, but ultimately everybody who can able to pay it, that can be measured in terms of V. Similarly, we have in Bitcoin also. Every Ethereum account have 4 fields, right? The code hash, counter, balance. Now we are into code hash and the storage root. Code hash, all code fragments. Like every code fragments are contained in the state database under their corresponding hashes. Hashes are maintained because anytime you can check the integrity of the code. Even 1 bit value is changed in the entire code, the hash value changes. That's a beautiful property of the hashes that we know. And 256 SHA-256 is used for generating the hash code. So these hashes can be retrieved anytime and verified. Of course, we all know that contract accounts doesn't have any code associated. So obviously, contract accounts have the code. Obviously, hash is generated on it. The externally owned account doesn't have any code associated. So it is the hash value of the empty string. The storage root is 256-bit hash value, which is a root of Merkle tree. All of you can go through that Merkle tree, what exactly Merkle tree, understand it, try to understand. And that encodes the storage content of the account. The third element of Ethereum ecosystem is transactions, right? Important thought. A transaction in Ethereum is a set of instructions, signed digitally with accounts, right? If any wallet or any account which wants to externally owned account wants to send a transaction, so wants to send it creates a transaction. So when it creates a transaction, it is being signed by it. So signature tells us that which account has created the transaction. The digital signature. All of us know how digital signature is a beautiful concept in cryptography, which you can identify who is the sender, right? And any point of time, sender cannot deny that only because the sender has that the key by which it will be signing. A transaction in the Ethereum is a set of instructions signed digitally by accounts initiated by external owned account, right? Contract account doesn't initiate, they won't create it, they only receive and send. So when the transactions are created, they are broadcasted into network. So when it is broadcasted into network, it changes the state of the EVM, right? Ethereum virtual machine, which is running in all the nodes, full nodes, right, in the network. So every node receives it, the transaction receives it. So this transaction changes the state of the EVM in every node. The simple transaction is transferring ether from one account to another account. The simplest transaction is transferring ether from one account to another account, which is equally can be compared with the Bitcoin transaction. But Ethereum can have more complex transactions where you can write the code. The code can contain what is the kind of contract being established between two entities. Why this ether being exchanged, right? What is the logic behind that? Why they want to do this kind of transaction? So that all you can do it in Ethereum, but not that much robust in the Bitcoin. So completion of transaction results creation of new control or message call. Miner can execute the transaction and propagate the result state into the network. Okay, just one second. Okay, sorry for the interruption. So, yeah, miners can execute the transaction and propagate the result into the state of the network. So once the transaction is transaction is submitted into the network, the miners will take that transaction and that mining pool, transaction pool. So they take the sum of the transactions and try to build the block. And we know that whichever the miner builds the first time, so once the block is built, the miner sends the block into the network for the verification and acceptance, right? That's the process in the blockchain. So once the block is accepted by the blockchain, the miners are paid for that, right? Whatever the transaction fee and the other details will be. So every transaction has certain information. That's a counter, a recipient of uh, the ether, and the code which are the part of it, the between two entities which has happened. Signature value, what is the amount of V which is being transferred. Data, it contains all the information, what is the logic, business logic that has been part of uh, the transaction. Gas price, and gas limit. The counter, as I told you, it keeps of number of transactions sent, right? Every the counter keeps on increasing. Sorry. The recipient is 160 bits of address of the public key, and signature is digital signature algorithm is used using elliptical curve digital signature algorithm, which is SECP 256 algorithm. The value of the which is contains the information about how much of ether being transferred, how much of V, right? That's the lowest denomination is being transferred. Data which is optional field, you need not enter anything data there, or it can contain other information, arbitrary data. Arbitrary data may be a code. A gas price is the amount of V which is required to execute the transaction, right? So whenever a transaction is being submitted, the account will mention how much of gas price it is going to pay for it, right? So that is a payment for the miners. And there is a gas limit also, right? Gas limit also tells us, like, what is the maximum amount of gas that can be consumed for the execution of this transaction. Why it is required, we'll see that. So ether is a cryptocurrency which is used here. Ether Classic, and two Ethereum blockchains are there now in the ID, Ether Classic and hard fork. And there was a successful hacking on Ether Classic. So that led to the new, it is a DO attack actually. And the hard fork version is mitigated for this DO attack, which is now hard fork is fast growing, current active. Ether is used to purchase the gas as a crypto fuel, right, which is required to perform the computation on the platform. In brief, I can tell, like, we have a bike, and bike keeps on running. How long it can run? As long as assuming that engine everything is perfect, so it can run as long as there is a fuel in the tank. Once the fuel is over, the bike stop running it. So a similar concept is involved here. Now, why it is required? I'll explain in the next slide. The denominations, as I told you, the lowest denomination is V, and there is a kilo V, mega V, a giga V, which are called as Cabase, Lovens, and Shannon, respectively. Then there is a micro ether, Zabo, which is called as a Zabo, milli ether, Fini, and finally ether, which is of 10 raised to V. Ethereum virtual machine. In brief, I'll explain it. I'm not going in Ethereum virtual machine. It's a simple stack. Ethereum virtual machine is simple stack. Based on the execution machine runs, it runs on bytecode instructions, similar to the one Java virtual machine, JVM. The instructions to transfer the system state, it keeps on changing. So it keeps on running the bytecode, and that changes the that transfers the state of the virtual machine. This compiles the code from high level language to bytecode, right? As I told you, you can write the code using Turing machine language. Any complete Turing machine language can be used for most of the Turing machine languages can be used here, Ethereum, to run the applications on EVM. It also executes smart contract code and broadcaster state. Once the smart contract is executed, its state is broadcasted into the network. Word size it uses 256 bits, which is a pretty large number, and it uses the big endian. We all know that what exactly big endian, and it uses K 256 hash code in elliptical curve cryptography. The stack limit is 1024. That's 1 byte, 1 megabyte, right? And 1 megabits, bits, right? Works with LIFO, last in, first out. This supports execution of handling of execution and exception handling. What exactly here? No enough gas, invalid instructions. These are the possible things which can occur by executing the code in the Ethereum. See, as I told you that there are millions of accounts in the Ethereum, and every second there will be a number of accounts which are will be submitting transactions in the network. Assume that the most of these have certain flaws in the code, or the code keeps on running for infinitely. So that is going to create a havoc in the Ethereum virtual machine, or ultimately the Ethereum virtual machine can stop working. How to avoid it? That there should be some certain limitations on how long this code can execute, how long the smart contract can execute. So there must be limitation. This limitation is implemented, enforced by implementing the gas limit, right? So this gas is like the certain gas, say 100 gas. When I say that 100 gas, for every instruction which is being executed, 1 gas is absorbed, right? So as I told you, it's a machine which consumes certain energy. So that energy is nothing but gas here. So once the 100 gas is over, then this code stops running. It means that you have reached a limitation. No more fuel is available. You stop execution. That's how it is being controlled, so that the virtual machine keeps healthy, right? Otherwise, what will happen? The codes keeps on executing. The flawed code can execute infinitely, and it will be a DO attack, right? Where distributed attack will be there, and virtual machine will virtually not available for the execution. No more transaction can be submitted, so it is going to be a havoc for that. So this is how it is being controlled, right? So the gas limits are being set there. So whenever there is invalid transaction or no enough gas is available, it sends a execution error which can be captured and displayed for the EVM is an isolated environment, right? It is totally isolated. It is not going to interact with the outside world, right? So this is made because it has to be a secured one. So it is not going to interact with the file system. It is not going to interact with the network entities because everything is on the network, right? So it is an isolated entity, so which has to be executed isolatedly, hence more secure and deterministic in nature. Obviously, the EVM will be deterministic in nature. In the sense, deterministic in the sense, like you have a transaction, and for certain set of instructions, certain set of inputs, always it should give the same output, right? Irrespective of whether it runs on the node 1 virtual machine, node 2 virtual machine, node nth virtual machine. It should always give the same result, right? So that's what the deterministic in nature, right? It cannot give, you should not give different results. If that is the case, then there will not be any consensus in the network. So Turing complete machine, but it's limited by the amount of gas, right? That is required to run any instruction. It cannot run infinite, it cannot go on infinite loop. Means you can always control the denial of service attack. So there cannot be any infinite loop. So gas solve the halting problem where EVM keeps halting. So that problem is solved here. That's a reason for the gas to be introduced here in the Ethereum ecosystem. So what was the problem? The problem is cannot tell whether or not a program will run infinitely from a compiled code. Right? You cannot tell it unless the compiled code runs on the virtual machine. So how to control that is the solution is charge a fee per computational step into limit the finite loops, right? And stop flawed code. If it is not completing execution of the code within those many steps, then stop execution of that code. So every transaction need to specify estimated amount of the gas. So I want to submit a transaction. I need to specify there how much of gas I can spend on it. So it essentially measures how much of one is willing to spend on the transaction, right? So that's what the transaction. So when it is executed, a miner try to create a block for that. So they will be using the this gas price. So gas price keeps on changing. You can see the current gas price. It is in terms of V's, which is available in that website which I mentioned there. It is always set before the transaction, before a transaction by the user. Gas limit is the number of gas amount of the gas which is you can use or willing to spend for the transaction to be recorded, which helps us to regulate the load on the network, right? All these things I have already explained. We'll go to the next one. Okay, so Ethereum virtual machine state, as I told you, it keeps on changing. Machine state maintained by the EVM. It is updated after each execution cycle, and it is tuple consists of available gas, program counter, content of the stack, active number of words in the memory, all these things. Some more information you can get it from websites. The books which I have mentioned in the last slide. So the last element in the current discussion is smart contract and Oracle, right? Smart contract, which was not there in the original Bitcoin version, right? The concept was not introduced there by the Satoshi Nakamoto, right? But as over the time it is being evolved, the smart contracts have become very important part of the blockchain. This is proposed the first time by Nick Szabo 1990, writing in a paper there, which is available in the website. So I'll read this exactly what it defined as smart contract. Smart contract is a computational transaction protocol. Terms of a contract, right? The general objective of the smart contract design are to satisfy common contractual conditions such as payment terms, liens, confidentiality, and even enforcement. Minimize the exceptions, both malicious and accidental, and minimize the need for trusted intermediaries. Related economic goals, including lowering the fraud, loss, arbitration, and enforcement cost, and other transactions cost. Right? In summary, if I say that the smart contracts were brought into the picture so that you can reduce the middleman here. And also, you can write a code which contains what exactly it is your business logic. Because of that, you are trying to do the transaction here, right? And at the same time, it also maintains the confidentiality and payment terms. All those things is a part of it. So that can be produced as a code here. That's the beauty of smart contract concept. So Bitcoin smart contracts are very, very limited. No need of trust and no need to be trusted third party in a Bitcoin, but smart contracts are very limited. Smart contracts in Ethereum are more robust. Smart contract is a secure and unstoppable computer program, representing an agreement that is automatically executed and enforced. So smart contract can be enforced. They are secure and stoppable. It should be accepted by the, question arises, can the court of law accept it? Court of law doesn't understand the code. The court doesn't understand the court of law's legal agreement. We all know that there is a legal agreement, a green page, which is a long page legal paper, which consists of certain stamped, all those things, certain words written, typed, and signed by the various authorities, including trusted party. But court doesn't understand all those things, right? So the question arises, all these smart contracts are really smart enough? So there is a gap between, real world and blockchain. Blockchain world wants to build an empire where we have entities. Every entity may not know the other entity in the network, other node in the network, but they want to do the transactions as if the transactions are happening with well trusted entities, right? And there is a solution available for every every dispute that may arise due to the transaction. So that kind of world the blockchain wants to build. But you know that all these things are happening using a code, the computer which can understand it. But outside world doesn't understand the code. I cannot produce a code as a legal agreement between two entities in front of the court of law and prove that this is what exactly happened. Court of law doesn't agree with that, right? So there is a gap between real world and blockchain world. But we know that the smart contracts and blockchain is deterministic in nature. The question arises, when I say that the deterministic, the real world entities, now all of us know that there is a AI, ML, which is coming up. AI and ML, probably in some cases, they don't agree that all the time it has to be deterministic in nature, because it has to learn from the world. So what is the output now may not be the same output over the certain time once the machine learns about the things, rules and regulations. But that is not expected. What is expected from the blockchain is, for a transaction, for a given set of input, always there should be a well-defined output that deterministic in nature, right? So there are questions about the smart contracts. It's being evolved over the time. There's a lot much has to be done, and there should be some domain-specific languages which can understand and write a code. That code should be acceptable by the court of law, right? These are being explored in the research avenue. There are certain domain-specific languages like Solidity is there, which are being, and mostly in fintech companies which are exploring blockchain as their the never-ending solve the never-ending problems, to solve the disputes faster. All these things are possible there, right? So smart contracts, what properties are expected is they must execute automatically. They are enforceable, right? And semantically sound enough. In the sense, when I write a code, the code should be semantically accepted. Anybody who doesn't know that Turing language, programming language, should be able to understand what exactly the logic behind the smart contract. That's what semantically sound enough. Secure and unstoppable, right? They should be executable, securely executable, and nobody should tamper with that, smart contract execution. The first two are the minimum requirement, automatically executable and enforceable. Other two depends upon the scenario. We all know that semantically sound, it is very difficult, where the court of law doesn't understand the code. Example, financial derivatives, sale deeds, all those things. We can give that so many examples. So I want to pay a certain amount of ether for a property which I brought it from somebody. So I can bring it into Ethereum. Okay, there was a disturbance. It's a work from home for us, so you'll find a lot of disturbance during the talk. Okay, so there is what is the solution for this? Ricardian suggested one solution for this. The solution is the Ricardian contract by the Ian Grigg, who proposed in a paper Financial Cryptography in 7 layers in 1990. This has happened in 1990, right? Which is quite long back, but it is very relevant to current scenario where you can write the smart contract. The initial design was on a bond trading payment system called Ricardo, right? Ricardo never thought that it is going to be a blockchain going to rule the world, but his idea was to have code written which can understand both by the computer as well as the court of law. The idea is a document understandable and acceptable by both court of law and computer software. What are the desired properties that are expected here? A contract offered by the issuer or holder, right? And a value right held by the holder and managed by the issuer. There are two properties, holder and issuer. Readable by human, readable by Turing language, computer. Digitally signed, has information of keys and server information, and it has a unique identifier. I mean, any transaction, any number of transactions can happen, but there should be a unique identifier for every transaction that's being executed here. That's what expected here. How it is observed? Ian and Grigg in that's in 2000. In the next, so you notice here there is a written document, right? And this document is written on a valid document signed by the third party, right? You can verify with the, this is the entire document is signed using a PGP, pretty good privacy signature algorithm. And this written contract is a legal prose, including some machine readable language. There will be tags here, so that can be written here. So this produces a hash code. And of course, this will be a unique hash code because the contract can, which a document can produce always a unique hash code. Message digest is created. So we have moved to the world of cryptography, right? Then there is this will create a node here, hash code. Then you can create various, the hash codes and build a transaction. So this is how the Ricardian contract was thought of, a bow tie model, where it can be accepted by world of law, world of cryptography, world of accountancy. But it is noticeable thing is here, a written document is scanned, its image is converted, a hash code is generated on the image, right? That's what the thing. The performance and semantics, in the sense how the performance will be and what is the semantic, which are the orthogonal issues, which is written in a code, is more readable by the computer, but it is not acceptable by the court of law. Whereas a Ricardian contract is more acceptable with the court of the law, but a smart contract cannot accept it because it is more on the code, right? So what is expected here, you need to build a smart contract which is acceptable at the court of law and smart enough to execute on the blockchain. This is what expected. A lot of research is being going on. So there are domain specific languages are being built on to develop the smart contracts, specifically in financial sector, because where the need for the is tremendously increasing in a nowadays. So this idea floated by the Clark, this paper smart contract templates foundation, right? Designing the landscape and research directions in this paper. So idea is to build a standard template that provides a framework to support the legal agreements for the financial instruments. So the idea of legal pose can be linked with the markup language, right? There's a markup language, specific domain specific languages can be used. Of course, this is an open research area where you can put up your thought and build your own, system here. Solidity and Viper are the such domain-specific languages on Ethereum platform, where you can try to build smart contracts. Oracles are the, as I told you, Ethereum, works in a very secured environment. Ethereum virtual machine doesn't interact with the outside world. So what is expected? Any information to be flowed from outside world, it has to come through the Oracle. I can give one example. Say, for example, you are writing a smart contract, right? And this smart contract has to be executed on 31st March, is a financial year ending. You are the owner of the company. You write a smart contract that every employee of the company must be paid what do you call the dividend, right? Bonus, depending upon the number of the stock they hold, about the company stock, the current company stock. So, and also the bonus should be dependent on the current stock value. So there are two factors which are going to decide. One is at the given instant of time, how much an employee is holding the number of stock, and what is the value of the stock at that point of time. So this has to be executed on 31st March, right? So how the virtual machine or the smart contract know the current value of stock and the number of transactions held by an employee, right? So this can be obtained only from the outside world. So there are two entities which can pass the information through the Oracle. So Oracle comes into the picture because Oracle is going to be a trusted party for the virtual machine, which can trust it that this is the information is being transferred, which doesn't contain any malicious information correct information, contains correct information, all those things. So that's the reason the Oracle always can verify the information, and it can verify from the current database that how many employees are holding how much of stock, and it can also verify with the Bombay Stock Exchange what is the current price of the stock. The two information which can send at that moment, and that will decide the what is the value of the bonus that is being should be given to the employee. So that's the reason Oracle plays a very important role here. So DO is a smart contract. Ethereum blockchain are usually part of the broader applications such as DO, which is a crowd-funded in 2016 set of smart contracts written to provide the platform for investment, which was hacked in earlier 2016. $15 million were stolen from the accounts. But it was not really hacked, but unintentional behavior that program of DO did not foresee. So that led to the hard fork Ethereum, where the gas concept was brought. The other Ethereum classic need, there is a need for the formal languages to develop the verification of the smart contract. So if I come to a conclusion, I think I am on time, right? So Ethereum is open source, which is built blockchain-based distributed computing platform, and which is an operating system feature for a smart contract functionality on the virtual machine. So Ethereum is the most popular permissionless blockchain where anybody can join the blockchain without any permission. They can have their own account. You want to have a full-fledged account, you need to pay for that. If you want to have only hold certain for the V, the other account which is free of cost. It supports smart contract, allows any user to create an account on it. No limited on cryptocurrency, right? Open for innovations. That's the most important part for the current FDP program, where you can put your ideas and build your applications, deploy them, run on them, test on them, right? All these things are possible. So this is all about Ethereum. The two main the books and the research papers which I have mentioned here, Ethereum development documentation from the Ethereum website itself, you'll get a lot of information there. And one book which I have found it interesting, Mastering Blockchain by Imran Bashir. It's a packed one. The third edition available, which I used the second edition. The third edition is now available in the market. So this is all about today's talk. Now, open for question and answers. Moderator, you can come in.
So there's one question in the chat box that is buying and selling either illegal in India.
Yeah, that's what the question is now. Because we are trying to do these things, we are not trying to do directly here. There is a third-party agency which always takes care of buying and selling. Notice here, if you want to buy a Bitcoin, you cannot buy a Bitcoin directly. There is a third parties which are involved, and these parties are registered with the government agencies here. So as of now doing this directly is not possible, but indirectly through the agencies which are registered with the government, they are doing the transactions, and they are keeping everything recorded there. They submit the audited documents to the government, so it's all legal. That is legal, but you cannot do that directly. And I can do direct transactions with anybody in the world with a Bitcoin or Ethereum. That's still it's going on. Government is open for it. They are trying to because it is going to be an open world one or the other day. So, but again, there are so many issues, no? Security issues are there. We see a lot of problems every day that it's this kind of platforms are being misused for transferring money for illegal activities.
The next question from another person, that is, what are the chances of this
Yeah.
Ethereum system getting banned in India?
So as of now, the current system, if you look at, I don't think there will be a ban on Ethereum or any other blockchain system.
So there's another question.
Yeah,
There was
for the participants, I want to tell you that this part I haven't gone through. This is more on legal issues. Can you focus on technical aspect of the blockchain platform? This is more on a technical talk rather than the legal issues. Probably I am not the right person to answer these legal issues, questions here. Yeah, please note this point, and whatever I tell may be correct or may not be correct regarding the legal issues.
So, dear participants, please post your questions in the chat box so that sir can answer. So there was one question that why a block needs to be validated.
Yes, see, block once it is created, one of the node creates a block in the network, but there are n number of entities. There are there's so many entities, so many nodes in the network. So once the block is created, all the nodes have to accept it, right? And then when it is accepted, that will be part of continuous chain, that is blockchain, right? So this acceptance happens only when they verify it, right? Verification has to be done. Once it is verified, then everything is okay, then it is accepted. So there is a consensus mechanism is being used, various consensus mechanism being used for that.
Participants, please ask your questions. So what is the role of miners in blockchain?
See, miners, if they create, there are number of nodes are available in the network. Anybody can join it. But if you want to be a miner, you need to pay for that. You have to create a kind of, infrastructure for mining, all those things. So I told you there are two major consensus algorithm. One is proof of work and one other one is which are available there. The Bitcoin and Ethereum current versions, they use proof of work as the mechanism for the creating. When a transaction is submitted, all the full nodes, those having the infrastructure and have a permission to create the block, they'll start exploring. That is what we call it as a mining, creating a block. When they, depending upon the difficulty level, there is a difficulty level set by the blockchain itself, right? Which is on consensus. So any one of the node or number of nodes at a given point of time, they create a node, create a block which satisfies that condition, right? Then they can say that the miner can say that yes, I have created a block. When they create a block, then they send it to the network for the acceptance. If only one node is created, obviously that node is block is verified, accepted by all other nodes. But if more than one nodes are accepted, then there is a conflict which occurs. Say I am the next node. I receive a block created by X node, right? Then the Y node also sends it. But I have already received a node which is a valid one from the X. So what I will do is I'll accept the X node's block. Then I will append it to my blockchain, which is there available. So similarly, all others nodes do this. So this keeps on. Some of the nodes will have the block created by X. some of the nodes will have a block created by the Y, right? But what happens over the time, only one of the blockchain keeps growing, the other one stops growing. So that point of time, all other nodes will try to sync to the see which of the chain which has grown more, right? Say if X block is grown higher, then that is accepted as the blockchain. So this is how the blockchain is accepted, and blocks are accepted. That's the reason there is a delay in Bitcoin. If you see that on an average, there is a 10-minute delay in every node which is created. In the sense, when I submit a transaction, I am sure that before 10 minutes, this transaction is not going to be accepted, right? Even if it is, I am going to pay a next person who is sitting there to me physically, right? It will take at least on an average of 10 minutes, because a block has to be created, which has to be accepted. Once it is accepted by the blockchain, that it is comes into the complete chain. Otherwise, it will be discarded.
Thanks. So any more questions from the participants?
Who is the moderator here? May I know?
I have myself Firoz.
Firoz, yeah, good, Firoz. May I know the background of all the participants here? Thanks, Shalini and Jason, Jalaluddin for the comments.
So most of the participants are from computer science background, computer science, information
Yeah,
technology.
wonderful,
background.
wonderful. Yeah, wonderful. Okay, good. Kamlesh, thank you.
I think there's no more questions. So shall we wind up the session, sir?
Yeah, sure.
Okay.
Firoz, thank you very much. Thanks for first of all, I should thank all the participants listening to me. I could have made it more robust if I had information about what are the other sessions in the blockchain, the entire FDP. Somehow there was, like, I did not get the complete details. That's okay. I hope all of you have enjoyed this session. There's a lot more in blockchain. You can start with the blockchain basics and then go to the specific blockchains. One which probably I would interested to take up somewhere if I get a time, as IBM Hyperledger, which is coming up with a more applications. There are various applications. In fact, if you are connected with me in LinkedIn, I keep posting about blockchains, and there are big players into the blockchain like Facebook, IBM is companies. They want to bring their their infrastructure into the blockchain network. And very interestingly, now you can build applications, you can build your company, and which can give us solutions on blockchain. Probably the best example, best scenario I can give, current the agriculture system, where a farmer can sell the products anywhere across the world. The blockchain can be a best solution for it, right? You can build an application where farmers, various entities can join the system, and they can interact, and which is we can create a trusted ecosystem where every entity can trust each other sitting across the world, right? There are good examples of it. Please go through them. Try to do the best thing.
So thank you,
Thank
sir.
you for the organizers. Thank you, Pramod. Thank you, Ravi sir. Thank you very much.
So thank you, sir. So on behalf of my coordinator and Department of Mechanical Engineering, Tkmce College of Engineering, I heartfully thank Dr. Rajendra Ekadi for giving a wonderful session in spite of his health issues, and also we were actually contacting him 3 days before. So even though he accepted my accepted the invitations. Thank you so much, sir, for that. And thank you so much for the wonderful sessions. Thank you, sir.
Thank you. Thank you very much. Have a good day.
Thank you.